Assalamu alaikum students. Welcome to another lecture of Cambridge Maths Sub as we have going on with chapter number 14 probability. So today we are going to discuss the next exercise that is related to your calculation of the probabilities. Okay. In the previous exercise what we discussed that how we can find out the probability on the basis of the probability that have like with some kind of certain events and with some kind of non-certain events. Okay, so the certain events were having the probability 1 and the non-certain events were having the probability 0. Now, in this exercise, what we are going to do is we are going to calculate the probability. And this is actually the formula you can say that we can use to calculate the probability of a success. Means the probability that is like we are able to find out the probability or there is like certainly that there can be the event. So what we can do, the probability of success, we can just find it out in a way like for example, any kind of probability with any event is going to be S over N. What basically S over here represent, S means the probability of success, okay, or where we are interested in, or you can say number of favorable outcomes. Both can be fine, okay. Probability of success, and this basically represents the total number of ways, okay. If with a simple example, if we will just discuss this one, for example, if we roll a die, we will be having how many total possibilities? 6 possibilities. 1, 2, 3, 4, 5, and 6. Okay, total 6 ways we have. If we will just roll a die, either we can have the number 1 up till 6. So if for example we are interested in to find out what is the probability of getting a 3 when we will roll a die. So how many times we have a 3 over here? Only one time we have a 3. Out of total how many possible events? Total 6 possible events. Okay, in this way the formula in which we are interested in or number of favorable outcomes, you need to write it above, and the total number of outcomes or total number of ways, you can just simply write them down under. Okay, this was the simple example, and using this we are going to calculate the probability. How we are just going to directly go on with that for your exercise 14.1b, and let's just start. So when we are going to find out the probability, we must remember this formula in our mind. So let's get started. So exercise 14.1a, this is related to your calculation of the probabilities. So the first question over here is, this is your question. A fair dice is rolled once. Find the probability of obtaining a 6, an even number, a number greater than 3, and a number 3 or 5. Okay, so we are going to start with first question of your exercise 14.1b. Now here what we needs to have, we must know what is our total possibility or total probability or total number of ways, and what is the success that we are just interested in. Okay, so the first part, what they're saying, a fair dice is rolled, just one fair dice has been rolled. So if we will be talking about the possible outcomes or the sample space that we are going to have accordingly, sample space, so that's going to be the numbers 1, 2, 3, 4, 5, 6. This is our sample space according to one dice when it's been rolled. So first of all, the first part, A part, is that we need to find out the probability of getting a 6. Okay, so if we need to find out probability of getting a 6, how many times we have 6? Only one time out of total 6 possible outcomes. Okay, so simple is this. So next B part is that we need to find out the probability of an even number. Probability of an even number. So if we need to find out the probability of an even number, how many times an even number is there? We have 2, we have 4, we have 6. So 3 possible outcomes are there for getting an even number. out of total again 6. So this can be simplified as well, like 3 1 times and 3 2 times 6. So 1 over 2 is the probability of getting an even number. Okay. Similarly, if 1 over 2 we are getting, so probability of odd number will be also 1 over 2. Next C part is that we need to find out the probability of a number greater than 3. So probability of number greater than 3. So if we need to find out the probability of number greater than 3, we have three numbers over here. If you will see, number 4, number 5, number 6. So three possibilities we have over here again. Out of total 6, so probability for this event as well is coming as 1 over 2. Okay. Next, the D part over here, if you will see what they are asking in there, we need to find out probability of 3 or 5. Okay. Probability of getting a 3 or 5. So how many times we have a 3? Only one time we have a 3, right? And how many times we have a 5? Only one time we have a 5. Okay. Probability of 3 or a 5 we need to get now. So for this one, what we will do, only one time we have 3 and only one time we have 5. So 2 over 6. Okay, 1 times this and 1 times this. So this is going to be 2 1 times 2 to 3 times 6. So 1 over 3 is the probability of getting a 3 or a 5. Okay. So this was your complete question number 1 related to your exercise 14.1b. Next, moving towards your part number 2. In this, they're saying that the two sides of a coin are known as head and tail. Like if you will just roll a die, we were having 6 possible outcomes. But if we have a coin, so we will be having either head or either tail. So a 10C and a 5C coin is being tossed. So basically they're talking about two coins that have been tossed at the same time. So first of all, we need to enlist all the possible outcome that there can be, because if we have two coins, so there must be two heads and two tails, but there can be some kind of sample space that will give us all possible outcomes, and then we will be finding out these two probabilities. Okay, so moving towards part number 2 of this exercise. First of all, let's create the sample space. Okay, you can have the sample space in two ways. Either you can create the box diagram or either you can go with the tree diagram. Okay, I will show you the both. So let's go on with the box diagram first of all. So for going on with the box diagram, what we will do, we will just create a box over here in this way. That as we have the two heads and two tails. So like two coins if we have, so how we would be going on with this? Let's see. Okay, so first of all, we have head, tail for one coin, that is 10C coin. Okay, for 10C coin. And for the second coin, we are going to have again head and tail, and this is going to be for 5C coin. This is going to be for 5C coin. Now, what would be our sample space? First of all, we're going to have head and head. Both would be head and head. Then we are going to have head and tail. Then tail and head. And then tail and tail. So how many possible outcomes we got? 1, 2, 3, 4. 4 possible outcomes. You can write them down in sample space. Head, head. First we have head, head. Then we have head, tail. Then we have tail, head. Then we have tail, tail. 4 possible outcomes. So this was basically the box diagram. But if we would be going on with the tree diagram, let's see how it would work. Like we have two coins. First of all, we have 10C coin. So this is going to be head and tail. The second coin is going to have again head and tail, and head and tail for this category as well. Like we need to check that how many possible outcomes we can have with these. So we can have again 4 possible outcomes. Head, head, first of all, then head, tail, then we have tail, head, and then we have tail and tail. So either we can go with the box diagram or either we can go with the tree diagram. You can check both are giving us the same possible outcome. So here we got the sample space right over here. Now accordingly they are asking like A part we have done that we need to create the sample diagram, basically your sample space. So this is your A part. In the B part we need to find the ability of getting two heads, a head and a tail. Okay. So first of all, in the B part we need to go with the probability of getting two heads. Okay. So how many times we have two heads? Only one time we have two heads. Rest are having only one head. So 1 out of 4. Only one time we have two heads. Rest all are different. Okay. Second part is probability of getting a head and tail. So this time we need to find out the probability in which we have head as well and tail as well. So if you will see, we have head tail here, we have tail head here, like both are the same possibility. So we would be going on with the two possibilities out of total 4 possible outcomes. So this can be simplified as 1/2. Okay, so this was your complete question number 1 and 2 of your exercise 14.1b. Now let's move towards next question, part number 3. So let's see what they gave us in part number 3 over here. This is your part number 3. In this, they're saying a bag contains 6 red balls and 4 green balls. So find the probability of selecting at random a red ball and a green ball. Okay. So the third part. First of all, we must know how many total balls we have. Okay. We have been given with the two colors ball. The total balls what we have 6 red balls. So 6. And we have 4 green balls. So 4. 6 plus 4 is going to be 10. Total 10 balls we have. So if in the A part, what we are going to find it out is, first of all, the first part is the probability of getting a red ball. So how many red balls basically we have? We have 6 red balls. Out of total 10 red balls. Just the way I told you the formula, S over N means your success and the total number of outcomes. So accordingly, number of success I've written above and total number of outcomes I've written downward. So 2 3 times is 6 and 2 5 times is 10. This is your probability of getting a red ball. Okay. Second part for this question, same question, is that probability of getting a green ball. So if we need to find out the probability of getting a green ball, how many balls are green over here? There are 4 green balls out of total 10. So this can be also simplified to 2 times 4 and to 5 times 10. Simply that is, okay. All right. This was your first part. In the second part, in the part B, they're saying one red ball is removed from the bag. Now, if one red ball is going to be removed out of total 6, there will be only 5 red balls. So obviously the total number of balls will be changed for the B part. Okay. So accordingly, we need to find the new probabilities of selecting a red ball and a green ball. Okay. So let's see for the B part, as your one ball is going to be removed. So total balls will be change. So this time we are going to have only 5 red balls and 4 green balls. Green balls will remain same. So 5 and 4 would be 9. So let's find out the probability. In the first part, we need to find out the probability of the red ball. So this time, as we have only 5 red balls out of total 9. This can't be simplified. You can just keep it as it is. And second one is probability of the green ball. So how many balls are green over here? 4 balls are green, but again out of total 9 balls, because one ball was being skipped. So this is the thing, that if we are going to go on with the probability and we are just making our total number of outcomes, or we are changing it, so obviously the probabilities for those outcomes will be also different. This is the thing. All right, hope so this question as well is clear. Now let's move towards part number 4. In this, they're saying one letter is selected at random from the word unnecessary and find the probability of selecting these letters. Okay, so the word over here, how many letters basically do it basically has? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Total 11 letters we have in this part number 4. So let's start part number 4. First of all, we must know how many total letters of word. So we have U double N E C E double S A R Y. Okay, so this is basically the letter we have. So we need to check how many total letters we have. We have total 11 letters over here. And from this, we need to find out the probabilities of some of the letters, not all. So let's find out the probabilities one by one. For example, in the first A part, they are asking that we need to find out the probability of an R, only one R. How many times there is R? Only one times there is R out of total 11 possible outcomes. Next, the part number B, we need to find out the probability of getting an E. How many times we have E that is being repeated. So we have only E over here and here as well. It means that 2 out of 11. As these can't be simplified, so you can keep that as it is. Okay. Next, we have O and C probability. So C part is probability of an O, getting an O. There isn't any O. So probability will be directly 0 because there is no O. Okay, so C, after that we have D, probability of getting, what was that? C. Probability of getting an C. Okay, so if we need to find out the C probability, only one time again we have C out of total 11. In this way, they can give you any kind of sentence. So accordingly, if they are asking that some kind of letters, or the probability, just you need to check how many total things or total letters are there. Accordingly, the number of possible outcomes or the possible outcome where you are interested, you can find out the possibility. This was your question number 4. Now let's move to the fifth part. In this fifth part, they're saying 3 coins are tossed at the same time. So this time they're talking about 3 coins. Previously, we got 4 total possible outcomes when they were talking about only 2 coins. Now they are talking about 3 coins. Okay. So 3 coins are there. They are being tossed at the same time. First of all, we need to list all the possible outcomes, and accordingly, we need to find out 3 heads, no head, 2 head or 1 tail, and at least 1 head. So let's do it in front of you. This I'm just going to erase so we can do it in front of you. So let's go on with the fifth part. First of all, again, if we need to find out the total number of possible outcomes, we can go either with the sample space or either we can go like using the tree diagram, either we can go with the box diagram. But for these kind of question, I think so tree diagram is basically quite reliable. So we have 3 coins. So first coin, head and tail. Second coin, head, tail, head, tail. Now third coin, head, tail. With every branch, you need to make two more branches and you can just exceed. Okay. Head, tail, head, and tail. So in this way, we have 1, 2, 3. 3 coins possibility. Now just enlist them every like possibility. For example, for the first one, head, head, head. This is your first head, head, head. Next is head, head, tail, head, head, tail. Next we have head, tail, head, head, tail, head. Next we have head, tail, tail, head, tail, tail. Then we have tail, head, head, tail, head, head, tail, head, tail, tail, head, tail. Okay. Next we have tail, tail, head, and last we have tail, tail, tail. It means that how many possible outcomes we have? 1, 2, 3, 4, 5, 6, 7, 8. 8 total possible outcomes. So we have these over here. Let's erase it and then just find out the question number. For the question number 5, we are going to find out the answers. Okay. So first of all, total possibilities. There are total 8 possibilities. So in the A part, what they are asking, let's see, they are asking of probability of getting 3 heads. Probability of getting 3 heads. So how many times we have 3 heads? If you will just carefully check all the possibilities, only this is the possibility where we have all 3 heads. Rest are only having either 2 or either 1. So 1 out of total 8. So simple as this, okay? Next part number B, we have two heads and one tail. Probability of getting two heads and one tail. They're not specifying that either tail will be first or head will be first, just two heads and one tail. This must be the possibility, and accordingly we need to check. Okay, so two heads and one tail, two heads and one tail, two heads, one tail. So three possibilities. Rest all are having one head. Okay, so we are going to have how many? Three possibilities out of total eight. Okay, simple. Next, after that, we have C part of getting probability of getting no head. This is so simple. Only this is the last possibility where we have no head, like all our tails, okay? Rest all are having either one, two, or three heads. So only one possibility is there out of total eight that this having no head. Okay, next D part is probability of getting at least one head. Okay. So if we needs to go of probability of getting at least one head, let's find out. At least one means that there can be more than one as well, but at least one head. So one, two, three, four, five, six, seven. All of these are having at least one head. So seven possibilities are there out of total eight. So this is so simple way of finding out the probabilities based on the formula that I just told you. This is your part number 5. Hope so this part is clear. Now let's move to the next part number 6 of this exercise. So moving towards part number 6, in this they're saying a bag contained 10 red balls, 5 blue balls and 7 green balls, and we need to find out the probability of selecting a red ball, a green ball, a blue or red or green ball. Okay, so for part number 6, again, first we must know how many total possible outcomes are there. Okay, so total possibilities you can say, or total possible outcomes you can say. Total possibilities. So we have 10 red balls, 5 blue balls and 7 green balls. So total 22 possible outcomes. Now for the A part, what they are asking that we need to find out the probability of getting a red ball. Okay. How many times we have a red ball? 10 red balls out of total 22. So we can simplify this as well, like to 5 times and to 11 times. That's it. Next is part number B. We have probability of getting a green ball. Only one green ball. How many green balls we have? 5. Sorry, these are the blue balls. Green balls are 7 out of total 22 balls. So this is the probability because this can't be further simplified. So we can leave it over here. Next, we have part number C. And this we need to go on probability of getting a blue or red. So if it needs to get a blue or red at the same time, so we can add them both. Okay, like here we have red, here we have blue. So 10 plus 5 out of total 22, that would be actually 15 over 22. This can't be also simplified, so you can leave it as a, okay. Next is part number D of probability of getting a red or green ball. Okay, how many red we have? 10 red balls and green are 7. So 10 plus 7 out of total 22. So 10 plus 7 is going to be 17 out of total 22. So that's it. This is your part number 6, sorry, part number 6 completely. Okay. Now let's move to part number 7. So in part number 7, they're saying cards with the numbers 2 to 101 are placed in a hat. So we need to find out the probability of selecting these. Okay. So if we are talking about the cards that are starting from 2 up till 101, it means that total 100 cards are there. Because if they are just skipping one from here, they are adding the one over here. So still these are 100 cards. Okay, so there is no need to count from 2 to 101 all the numbers. Just you need to just quickly count them down, that how many total cards are there in the box. Okay, so we are going on with part number 7. So first of all, how many total cards are there? Total cards from 2 to 101. Total cards are basically 100. Okay. So in the first A part, what they're asking you need to find out the probability of an even number. So if we need to find out the probability of an even number, if you know, like if we are counting numbers from 1 to 100, if one number is even, then is odd, even, odd, even, odd in this way. It means that if total 100 cards are there, so 50 would be even and 50 can be odd. Okay, in this way, quick calculation, 50 out of 100. So 52 times is 100. So simple as this. Okay, next is B part, probability, a number less than 14. Probability less than 14. So if we are starting the numbers from 2 and onward, so from 2, if we will be counting, so 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So total what we are going to have as we are starting from 2, so only 13 numbers, okay? 12 out of total 100. This can be also simplified, okay, like for 3 times and for 25 times is 100. Okay, less than 14 if he needs to go, but you need to just remember that the numbers are basically starting from 2. So 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then we are going to have 14. Total 12 numbers. Okay, next part number C, let's see what they are asking. In part number C, we are talking about the square number, probability of a square number. So numbers are basically starting from 2. So 1 is also a square number, but we will not count that. Okay. So how many square numbers are we have? We have 4, 9, 4, 4 times 16, 5, 5 times 25, 6, 6 times 36, 7, 7 times 49, 8, 8 times 64. And then we are going to have 9, 9 times 81, 10, 10 times 100. Okay, so how many? 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 out of total 100. Okay, these are the square numbers. And the last we have a prime number less than 20. So how many prime numbers? Prime numbers are going to be start from 2, 3, 5, 7, 11, 13, and 17. Yeah, these, and then 19 as well. Like these are the numbers that are prime numbers that have only two factors, 1 and the number itself. So 1, 2, 3, 4, 5, 6, 7, 8. 8 are the prime numbers. Okay. So B part is, D part is probability of a prime number less than 20. So how many were these? 1, 2, 3, 4, 5, 6, 7, 8. 8 are the prime numbers out of total 100. This can be also simplified like to 4 times, or you can go with the 4 for 2 times and 425 times 100. So that's it. Like we are going on up till part number 7. From the next one lecture, we are going to start from 8th and onward. See you until the next lecture. Allah Hafiz.